Hello, statisticians. Today's lesson is on describing two categorical variables. Let's jump in. From 2021 to 2025, the Las Vegas Aces dominated the WNBA, winning the championship in 3 of those 5 years, including back-to-back championships in 2022 and 2023, in which the team was led by this dynamic duo, A'ja Wilson and Kelsey Plum. Both Wilson and Plum are star players. In fact, in 2022, they both became the first players on the same team to each score 700 points in a single season. Let's take a look at the gameplay of these stars starting.
This is the matchup we came to see. Two of the best players in the world in Breanna Stewart and A'ja.
Contact? That's grown woman basketball right there.
Oh, she got
already a double-double for A'ja Wilson, who just recorded her 1,000th career rebound. Attempts. There's still essentially a full half left.
Young kicks it out. Wilson 0 for so far, but that's her first triple of the night.
Wilson is a tall 6'4" forward, and as you saw in the video, she uses that height and her skills to get past defenders to take shots close to the hoop. She does occasionally take longer three-point shots, but the closer two-point shots is what she's known for. And now let's see the other half of this amazing pair, Kelsey Plum.
first quarter, and that's one of the things Vanessa Nygaard talked about as far as rebounding.
Driving baseline, kicks it to the corner. Plum, three, splash.
And their home opener against Indiana.
Plum in the corner, in game. Atlanta struggling as far as turnovers.
Towards it. 2-for-1 opportunity if Vegas hurries. Plum charges in and flips it home.
Standing at 5'8", Plum doesn't have the same height advantage as Wilson. So as you saw in the tape, she shoots more longer range three-point shots, and occasionally she speeds past defenders to get layups closer to the hoop. In that impressive 2022 season, both Wilson and Plum were contenders for the MVP Most Valuable Player award. One criteria used to evaluate MVP candidates is their shooting percentage. That's shots made divided by the total number of shots taken. In other words, the percentage of shots you make. From 2021 to 2022, Wilson had a shooting percentage of 47.4% and Plum's percentage was 45.1%. So Wilson made a higher percentage of her shots. However, MVP voters also look at the type of shots into account. To discuss shot type, let's take a look at the diagram of a basketball court. Here you see a half court with the hoop labeled. This arc is called the three-point line. If you shoot from inside the arc, it counts for 2 points. If you shoot from beyond the arc, it counts for 3 points because it's a longer and more difficult shot. As we saw from the tape, Wilson usually shoots 2-pointers and Plum more often takes 3-pointers. To be fair, we should also look at each player's accuracy for each type of shot. Here are both players' shooting accuracies for each type of shot. As you can see, Plum had the higher shooting percentage in both types of shots. But hang on a second. Recall that Wilson's overall shooting percentage was higher, but somehow Plum had a higher shooting percentage among both types of shots. How is that possible? So, that paradox is the key question we'll try to answer today. How can a player be better overall, but also worse in each category? With that question in mind, we'll move into our notes. We're going to cover 5 topics today, starting with joint and marginal relative frequencies. Let's take a closer look at the raw data behind the numbers we saw earlier. Here are all of A'ja Wilson's shots from the 21 to 22 season, not including foul shots or free throws. This data is organized into a two-way table, which is a table of counts that describes 2 categorical variables. Note that sometimes these tables are also called contingency tables. The 2 categorical variables described in this table are the type of shot, 2-pointer or 3-pointer, and shot result, make or miss. A good first step for data like this is to find all the totals. Here are the totals. Let's break it down. The totals of the vertical or up and down columns are called the column totals. In this case, the number of 2-pointers she shot was 901. The totals of the horizontal or left and right rows are called the row totals. In this case, Wilson made a total of 467 of her shots. Adding up the totals for the rows gives us 985 shots, which is called the table total, or the total number of shots described in the table. We could add the number from the columns and get the same thing. Now, one statistic we might want to find from a table like this is a joint relative frequency, which is an individual cell divided by the table total. For example, if we want to find the proportion of Wilson's shots that were 3-pointers and missed, we can identify this cell that describes the 52 shots that had the joint trait of being 3-pointers and missed, hence the joint frequency. If we take this number and divide it out for the table total of 985 shots, we get a proportion of about 0.053, or about 5.3%. This means that 5.3% of Wilson's shots were 3-pointers that she missed. Now, one note on these tables. Sometimes, rather than showing the raw counts, two-way tables show the joint relative frequencies of each cell, or the counts of each cell divided by the table total. For these tables, the table total will always be 1, or 100%. So, back to the table of counts. One initial question we might ask about this table is, overall, how often did Wilson make her shots? To figure this out, we can find the proportion that she made and the proportion that she missed, regardless of the shot type. For total shots, we'll use this last column because we don't care if the shot was a 2-pointer or a 3-pointer. What we're going to do here is look at the margin. This is a marginal relative frequency, which is a proportion describing a category from one variable. Similar to how a piece of paper has a top margin and a side margin, each two-way table has one variable in the top margin and one variable in the side margin. The relative marginal frequency focuses on just one of these margins or one of these variables, and it's calculated by dividing the column or row total by the table total. Let's see how it works. To calculate the marginal relative frequencies for shots results, we start by looking at the table total, and we use that divided by the 467 for the shot type. So we divide these numbers and we get a percentage of 47.4%. So she made 47.4% of the shots that she took. If we look at the shots missed, we have 518 out of 985, which is 52.6%. So she missed 52.6% of the shots that she took. And as we can see, the percentage she made matches Wilson's overall shooting percentage we saw earlier. We can also take a look at the corresponding shooting data for Plum to verify her overall shooting percentage. With 372 made shots out of her 824 total shots, we get 45.1% made, which also matches what we saw earlier for her overall shooting percentage. After doing these calculations, it's often helpful to visually compare these sorts of figures. So how do we do that? We can do what's called a side-by-side bar chart. Here again are those marginal relative frequencies. To compare them, we place the percentages here in a side-by-side bar chart. So using this side-by-side visualization, what do we notice? We can see that Wilson has a slightly higher shooting percentage, which of course means that Plum has a slightly higher missing percentage. But what about the shooting percentage by shot type? For that, we'll need to calculate conditional relative frequencies. That is, we need to calculate each player's shooting percentage for each shot type. When we see this sort of language, for each, within each, or among each group, this means we need to find what's called a conditional relative frequency. A conditional relative frequency is the proportion of a subgroup that meets a certain condition, and we can calculate it by dividing an individual cell by a row total or a column total. Let's see how it works. So if we're looking at just among the 2-point shots, or conditional on the 2-point shots, we only need to look at the first column that describes the 2-point shots that Wilson took. We can ignore the rest of the table. So of the 901 2-pointers, she made 435 of them. Dividing these numbers, we get 48.3%. She made 48.3% of the 2-pointers that she took. That means she missed 466 of the 901, or 51.7%. So now we have the conditional relative frequencies for Wilson's 2-point shots. And we can do the same thing for 3-point shots. Among her 84 3-point shot attempts, she made 32 of them, which is 38.1%, and she missed 52 of them, which is 61.9%. So this is Wilson's shooting accuracies for each shot type. And if we go to the data for Kelsey Plum's shots, we can get these proportions for 2 and 3-pointers. So now, how can we visualize these pieces of data? For that, we'll use a segmented bar chart or a mosaic plot. For a segmented bar chart, we start by setting up these axes. This chart will describe A'ja Wilson. Here are Wilson's rates for making and missing the 2-pointers. We'll start with the shots made and create a bar. The height will correspond with her accuracy of 48.3%. And the remainder, the percent she missed, is graphed on top. Together, these categories will go to the top of the y-axis at 100%, meaning we've described all of her 2-point shots. Now we can do the same thing for 3-pointers, beginning with the percentage of shots made and stacking on the percentage of shots missed. And we end up with our final segmented bar chart displaying Wilson's accuracy rates for both 2-point and 3-point shots. Now, another way to visualize the same data is by using a mosaic plot, which is shown here. As you can see, a mosaic plot is very similar to a segmented bar chart, except in a mosaic plot, the bar widths are proportional to the sample sizes. As we saw before, A'ja Wilson takes a lot of 2-point shots close to the hoop and more rarely takes longer distance 3-point shots. So the wide bar for 2-pointers and the narrow bar for 3-pointers showcase this pattern. For our purposes, you'll only be asked to interpret a mosaic plot that is given to you or created with a tool like Kodak, rather than hand graph one yourself. So going back to a segmented bar chart, it shows that Wilson's shooting accuracy is better for 2-pointers than 3-pointers. And if we make a corresponding graph for Plum, we'll see that it's also true for her. With the mosaic plot, we can also see that Wilson makes substantially more 2-pointers than 3-pointers. And on the corresponding mosaic plot for Plum, we'll see that she's a more balanced player with taking 2-pointers and 3-pointers. What does this all tell us? We'll start with describing any association we'll see. One question we can ask is, does there appear to be an association between shooting percentage and shot type? That word association means, does the shooting accuracy differ between the shot types? So looking again at Wilson's shot accuracy between the 2 and 3-pointers, it appears that shooting accuracy is lower for 3-pointers. And that is also true for Plum, suggesting that we see a pattern or an association to consider. So when we're asked about an association, we can use our typical approach. Start with the big picture, the context, then look closer to make a claim, And finally, zoom in on the details that support your claim by comparing percentages between groups. And your claim will be much more effective if you use comparative language like higher, lower, similar, rather than just different. A description for this association might be: shooting accuracy appears to be associated with shot type. For both players, 3-point accuracy is lower than 2-point accuracy. For example, Wilson made 48.3% of her 2-pointers, but only 38.1% of her 3-pointers. Our claim is that shooting accuracy appears to be associated with shot type. We provided context by identifying the variables as shooting accuracy and shot type. And we support that comparison by pointing out that the accuracy for 3-pointers is lower, there's our comparative language, than the 2-pointers for the both players, giving Wilson's percentage as an example. So now we come down to it. Who is the better 2-point shooter? And who is the better 3-point shooter? Looking back at all of our data, and first considering 2-point shots, Plum is slightly more accurate at 2-pointers and at 3-pointers. She is also once again more accurate. So now we run all the numbers using the raw data, and the paradox remains. Overall, Wilson has the higher shot accuracy. But among both shot types, Plum has higher shot accuracy. How is this possible? So that is our discussion question for today. Specifically, try to answer this discussion question. Why is Wilson more accurate overall, yet less accurate with the individual shot categories? Explain your thinking. And here's an important hint to help guide your thinking. Take a closer look at these mosaic plots that we showed earlier. So when you're ready, jot down your initial thoughts and we'll discuss this question further in class. That's it for today, statisticians. We'll see you next time.